entered this class. So what is the Brillouin zone? If you look at the band structure of things that I have you guys plot so far, you always have energy. And I always give you the range of K from 0 to what? If you ever asked yourself, why are we going to just pi over A? Why aren't we going anywhere else? What's that? It is cyclical. Because really, we'll write the math down, but it is because it's a periodic function, right? This is what's known as the first Brillouin zone. Beyond that, we actually don't get much more unique information. So let's talk about it in the guise of the 1D chain. Oops. We have shown that, or at least I told you, if we're looking at some block function, some wave function, it follows this formula. Okay, what are these things again? Just to refresh our minds. Okay. Any of the coefficients or symbols or any of that stuff?
A is the distance between.
Yep. That's our lattice vector. Or I'm going to put unit cell length. We're talking about a 1D system. What else do we got? What's this guy? It would be in Gen Chem. Would be a mole fraction. What is it here, though? Okay, you could probably tell me what this is. What's that going to be equal to?
The sum of N, E, I, K, N, A.
Oh yeah, yeah, but I mean like, okay, what are these things? Yep, they're AOs. We're going to be a little bit more general and move a step back to be more general, a basis function, right? Okay. Okay, that would be more general, but in reality, these are our AOs because we're picking AOs as our basis functions in this class. Katie, when you go to do your project, are you doing solid state stuff with Dr. Pianka? Okay, if you are, basis function is the word to use. Okay, what else do we got up here? My buddy K, what's that thing? I know, I understand. Also with the buzz, I don't know, I was up super late last night watching the gambling odds.
Oh yeah,
K, what's K? Nope, not distance. What's K? It is a vector.
energy? No.
Does it involve the word inflection?
No. This is our wave vector. Okay, remember it keeps track of symmetry. I am a wave vector. We're all wave vectors. We're all waves just oscillating at the same rate, maybe? I don't know. A fun fact, if you want to see some really screwed up science, look up, what is it, grounding? Dr. Brown's been sending me all these like research articles about how you lay down on the ground and there's a frequency of the earth and it helps revitalize you.
That's why floor time works. Oh my god, that's crazy.
But there's no way it's true because the like frequency at which stuff's given off from the ground, like it all is different. Yeah.
just had a chem student prove that 5G doesn't give you cancer, so.
Did you really?
Yeah. But it wipes your brain, though,
Yeah.
through TikTok.
But 4G, that's
Yeah.
Yeah,
Okay.
Going lower in the frequency spectrum definitely makes it worse.
What about N?
Any pi.
Yep, it's just an integer. It's just an index. It's keeping track of which place in the line you are, right? Okay. What type of function is this? It's a yes, it is a wave function. It's unique in the way for what type of systems are we talking about? Yep, periodic. So this is a periodic function. Okay. Okay, recall, we've seen this, just talked about Euler's function, or yeah, formula. What else is that e to the I theta equal to? Yeah. Plus I sine theta, and we can represent any wave this way. We tend to use e to the whatever because it's just more condensed. Okay. So now the next question I ask is, why do we only plot from 0 pi over a for our wave vector? Yeah, periodic function. It's a combination of sines and cosines. We're just going to get the same thing over and over. We get redundant information. So what we're going to do now is we're going to make a plot where we're going to have K along here, energy along here, and we're going to move, we're going to look at it from a range of -2 pi over A to +2 pi over A. So here is 0 for K. And we're going to go to -2 over pi, or -2 pi over A, and all the way. I want this to look more symmetrical, so that'll do a bit better. Over A. And then we're going to mark another spot. Ah, damn it. If I cut in the dead center of these areas, what do I have? What will be my value, okay? Yep. So we get -pi over A along here. Here we get pi over A. Okay. Now let's plot this function. Can I do that in yellow? We've drawn this one a gajillion times. What's it look like? Yeah. Okay. Now let's continue it on. Yeah. Down she goes. Let's go into the negative region. Yep.
No way.
Yep, it was signed the entire time. Ah!
It's also.
Sponsored by M. Night Shyamalan. Okay. Now, where is the unique region of K? Unique region of K.
But technically, 2 pi over 8 count because it was up and then down and all not really kind of
Take your pick. Take your pick. Any pi over A.
So, if we look at the unique region, We take an absolute value, less than or equal to pi over a. This is called the first Brillouin zone. So on this plot, where's the first Brillouin zone? Mm-hmm. What about these regions? Yeah. So sometimes you might talk about multiple Brillouin zones, or you'll see pictures of multiple plots. Those can be important for what's known as a Fermi surface, where if we have enough time, I want to talk about Fermi surfaces. But you can look at a three-dimensional image and you can tell if the system is a metal or a non-metal by looking at that. Okay? Any questions about the Brillouin zone and why we're plotting from 0 to pi over a? Everybody good?
Wait, so what is the second one again?
Second one, it can tell you information about Fermi surfaces. And if a system will be conducting, or like how it can explain other strange behavior. That's all I really want to say about that right now. In this system, it looks the same.
Okay.
Okay? Everyone else? Yeah, go for it.
Is it unique? Is that space unique because you're getting one full oscillation?
Yes.
Okay.
Yep. The other thing is for this system, it's all just symmetric, so it's okay. You might get systems where that might not be true. The other thing is we're plotting only in 1D.
Yeah.
When you start expanding, we have more special points or different spots in reciprocal space we can go. Other questions?